So far in this chapter, we've seen how to add hydrogens, halogens, hydroxides in a double bond. But now we're going to see how to get an epoxide starting from an alkene. To get an epoxide from an alkene, we can use MCPBA, which is a peroxycarboxylic acid. You don't have to memorize the structure, but you must know that when we treat an alkene with MCPBA, CH2Cl2 is the solvent, we will get an epoxide. In this case, this molecule is symmetrical. But if imagine that we start with a molecule that looks like that it's not symmetrical, then what we can get is we can get the epoxide forming pointing up like this one, or we could get the epoxide pointing both down, right? So we will get a mixture of both of them, and you often are going to see only one of them, but keep in mind that both of them are possible. Again, for this reaction that we are seeing here, the molecule is symmetrical, so it doesn't matter if we point that epoxide up or down. But when we have a molecule that it's not symmetrical, you must indicate that both products can happen. You don't have to memorize how that epoxide forms, but what you must know is what I was saying, that the oxygen comes from the top or from the bottom, right? The alkene is here, and the alkene can be attacked from either the top or the bottom by that MCPBA, and that's how we get the epoxide pointing up, or we could get it pointing down when the reaction is not symmetrical. The stereochemistry is conserved. So what means is that when we treat an alkene with MCPBA, you see if both of our hydrogens are pointing towards one side, towards the same side, if the double bond is cis, then the reaction will be cis. Or if the alkene is trans, meaning that both my hydrogens are on opposite sides, the final product, the epoxide, also will be trans in the sense that the hydrogens won't be pointing into the same direction. Now, what is interesting about epoxides is how we open them. So an epoxide that looks like this one can be opened under two conditions. We could open it with a nucleophile, or we can open it under acidic conditions. When a nucleophile attacks, we'll simply attack in one of the carbons and then open up, and then what will form is this molecule right here. And by protonating that O, we will end up with an OH in there. The nucleophile will always attack the less substituted side, right? In this case, it doesn't matter because this epoxide is symmetrical, but we're going to see some cases where there is a more substituted side than the other one. And in the presence of acid, what will happen is that the epoxide will get protonated and then it will open up. In this case, because this epoxide, it will give us right here, see if that opens up like that, it will give us a primary carbocation. That's not going to happen, but we're going to see some examples where the carbocation that results is more stable. Let's talk about those two cases separately. So if I have an epoxide like this one, where one side is clearly more substituted than the other side, what's going to happen is that when I treat the epoxide with a nucleophile, is going to attack the less substituted side, which will be this carbon. That carbon is already saturated, so what needs to happen is that something must break. So as the nucleophile is attacking, the epoxide is opening up. This is an SN2 type reaction that as the nucleophile is attacking, the leaving group is leaving. And it's an intramolecular type of reaction because it happens within the same molecule. So what is going to happen is that I am going to get the nucleophile connected to that carbon right here. That carbon is going to open up, and then I get the O minus that just left. And then by protonating it, with any acid, I will get the alcohol, right? So in the presence of a nucleophile, such as CN, you've seen some of these nucleophiles. We've seen the thiols, the thiolates. The nucleophile can come, open up, and the nucleophile will end up attached in the less substituted side of the molecule. Now, if we take the same molecule and we react it with acid, right? This is the hydronium ion. What will happen is the lone pair will first attack the hydrogen, and the epoxide is going to end up protonated. So here, and now this will spontaneously open as the nucleophile is attacking. And so this epoxide could be opening in two different ways. Let's see what will happen if it opens from one side or the opposite side. If it opens from here, from that left side, what is going to happen is that the nucleophile that results from it is a positively is that carbocation that it's very stable because it's a tertiary carbocation. Okay, so if the epoxide opens, breaking that bond right there, this one right here, what will result is this molecule that will give us a tertiary carbocation. Now, if on the other side the bond that breaks is that one right there, what we will get is a different carbocation. I recommend you that you actually work this on your notebooks. And this is a primary carbocation. And as you know, primary carbocations are not so stable, so they are not so likely to happen. So the reaction that will actually happen is this one right here, where we go through a much more stable carbocation. And now what happens is, in this case, water left on the first step, right? So now water can come and attack there, and that will give us a diol actually, because it will give us this first, right? Because the water still carries both hydrogens, and then the last step will be that one of those hydrogens taken away by one of the molecules of water, and that will give us a diol. So the final product will be this one right here. Okay, so I'm going to repeat this one more time. When I have an epoxide that is not symmetrical, the first thing that happens in the presence of acid is that it will get protonated. And now that epoxide could open in two different scenarios. It could open giving us a primary carbocation that it's not likely to happen, or it could give us this more stable carbocation that is much more likely to happen. So this is not happening. And now, because we still have water in the reaction, if we started with H3O+, what will happen is that that water comes and attack. The water will attach like that. Still have that. And then another molecule of water can come, take away that hydrogen, and that's how we will get a diol. That's how we open epoxides under nucleophilic conditions or acidic conditions.